at this question. A cart M has block of mass small m in contact with it as shown in figure. Small m is in contact with capital M mass, right? And here what we have to do is coefficient of friction is given mu between these two masses. What should be the minimum acceleration of the cart so that the block of mass small m does not fall? Okay, so this small mass has tendency to move downward, and what force is acting on it? Small mg force. Earth is exerting this force on it. So to prevent it from falling, there must be an upward force acting on it, and friction will apply this force. But we know that value of friction force is mu times normal reaction. Mu is given in the question, normal reaction is not given. So now how much normal reaction will act on it? So since we are accelerating this system, so this small m force, this small mass m will be acted by a force in opposite direction, in this direction, which is equal to small m into a, right? Because pseudo force is given by mass into acceleration of the system, right, with negative sign. Suppose this entire system is moving rightward and a person is sitting on this capital M block, and this person is, so as we know that pseudo force is taken as opposite to the direction of acceleration of the system. So if this entire system is moving rightward with acceleration a, then a person on which is a part of the system will observe a pseudo force acting on this small block m, and direction of this pseudo force is opposite to direction of acceleration of the frame. Frame is accelerating rightward, so pseudo force on small m will act leftward. So how much pseudo force will act? Mass times acceleration of frame. So mf force will act on this mass in leftward direction. So this small m is exerting this much amount of force, mf force, on capital M. So capital M will also give normal reaction on small m in same amount. So this is also normal reaction force which is acting between capital M and small m. So put this value here. So you will get friction force is mu times m into a, and this friction force must be equal to downward pull, downward gravitational pull. So downward, because friction will act in upward direction here, so downward gravitational force is mg, and friction force which is preventing its downward motion is small mm. M will cancel out and you will get a equals to g upon mu, right? So this system must accelerate with acceleration g by mu to prevent this small m from falling down.